So let us see an example. Binding energy of a element is given 16a minus 28 to power 3 minus 3 by 4 z square a minus 1 by 3 plus 30 n minus z whole power square by a. So what is asked is the value of z for the stable isobar. So for stable isobar, binding energy is maximum. Therefore, dou B by dou Ez will be equal to 0. So let we differentiate the binding energy with respect to Z and we equate it to 0. We get an expression for Z. So differentiate. So since it is independent of Z, we'll differentiate the third term. We get 6 by 4 Z, differentiating Z square, and here we have n. Let me change to in terms of a. So a minus 2z the whole square by a. Let me expand this term. A square plus 4z square minus 4az by a. So now differentiate this term. So this will be 0. So we have 8z by a minus 30 into 4 a by a. Plus additional, this term is here. So we are having 3 terms here. So what we have to do now? So these are the 3 terms after differentiating the binding energy. Let me collect the Z term separately. Minus 6 by 4 plus 240 by a minus 120. So since it is for a stability, dou B by dou Z should be equal to 0. So bringing 120 to the left hand side. So taking this term to the denominator of the left hand side. Let me continue. So to cancel the above term, let me take 120 in the denominator outside. So we'll be having 2 by a minus 6 by 120 into 4 a power 1 by 2 equal to z. So cancel. So now let me take 2 by a also outside the bracket. 1 minus 6 by 120 into 4 into a by 2. If we take 2 by a, second term we have a by 2. So a 1 by 2 into a will be giving a 2 by 3. If we cancel this term, we get 160. So our answer will be 2 by a, 1 minus a 2 by 3 into 160 in the denominator. So let me bring this to the numerator. So z will be, so it will be a by 2 and 1 minus a 2 by 3 by 160 to the power of minus 1. This is the expression for Z for a stable isobar in terms of A. So what is given is the binding energy expression. From the binding energy expression, we can find the Z of a stable isobar. In the semi-empirical mass formula, we should know the contribution of each term in the binding energy expression. So in this problem, the surface energy per nucleon is asked. The ratio of surface energy per nucleon of aluminum and zinc is asked. So the surface energy contribution is directly proportional to A power 2 by 3. As it is per nucleon, it is A power 2 by 3 by A. That will be equal to A power minus 1 by 3. So, we have to find A power minus 1 by 3 for aluminium and zinc. So, for aluminium, A is 27 and zinc is for 64. So, 27 to the power of minus 1 by 3 and 64 to the power of minus 1 by 3. So, since it is minus 1 by 3, let me bring to the numerator. So, 64 power 1 by 3 will be 4 is to 3. This is the ratio of the surface energy of aluminium is to zinc.